I got a feeling ooh, that this section's gonna be pretty easy. But I don't know, cause I don't think all of them are that hard. This one might be pretty easy or easier, hopefully. Operations of polynomials. Okay, a couple things we're going to do. Polynomial is one or more monomials. Monomials, remember, is a what is a monomial? Oh yeah, I want to make sure I don't write it down so you have it. It's basically just a number, a variable, or a product or of numbers and variables. So like a number like 8, a variable like x, or a multiple of those would be like 8xy squared. Okay, those are all monomials. So monomials are just individual terms. So each of them are terms put together by addition or subtraction. All right, that's what a polynomial is, just a whole bunch of those. That stuff. Here's an example right there, right there. Each exponent must be a whole number. Okay, whole number means it's always positive. If we have a negative whole number or negative exponent, then it's not a polynomial. Okay, coefficients must be real numbers, real as opposed to imaginary. Real means like it can't be like pi. Okay, that doesn't work. That's irrational. Okay, real also it can't have i's in it. Like it can't be like 3i. That's something else. That's not a polynomial. That's called a complex number. We'll get into that later. Constant term. Boom, boom, boom. The only term without a variable. So this right here is a constant. So this would be the number 1. Degree, the largest exponent of the variable. Okay, so if I look here, I have x to the third and x to the fifth. So the degree of this polynomial function would be a 5 because that's the biggest degree. The leading coefficient is the coefficient of the degree term. So that would be -3 is the leading coefficient. Standard form is the degree term is written first and each successive term's exponents decreases. So in order to write this in standard form, this would be written as -3x to the fifth minus 2x to the 3 plus 8x plus 1. That is standard form for this problem. Now, if we had a 4 in here, then the 4, okay, if it was like x to the 4, then that would go in there. If we had an x to the 2 somewhere, that would go in the middle of there, okay? So that's very, very, very simple. All right, add, subtract, and multiply polynomials. So addition, I'm going to go through these real quick because I'm not going to spend too much time on them. So 6a to the third plus 6a to the third, 12a to the third. 5a plus a is 6a minus 2. That's your answer. This one here, these need to distribute the negative. Please don't remember or don't forget to do that. So it's -7x squared minus x to the 4 plus 7 would still a 4x squared plus 2 over there. I combine the x squareds to get -3x squared. I have an x to the fourth that I didn't remember I had, so that goes in front because it's bigger. And then 2 plus 7 is 9. Fantastic. This one here, remember I'm multiplying, so I got to make my box. So 7n plus 1, n squared, 6n and 3. 7n to the third, 42n squared, 21n. This is n squared, 6n and 3. And then I add terms on the diagonal. So 7n to the third plus 43n squared plus, was it 27n plus 3? Hopefully I did the math correct. Alrighty then. So difference of squares. What a difference of squares is basically both terms are squares. So we have two terms. We have two terms, and they are both square, perfect square numbers. So they are perfect squares. So they are both perfect squares. My handwriting is atrocious, but that's what I mean. They are both perfect squares. Holy cow, that's awful. So how do I get perfect squares here? Because t to the 5th and 16t is not perfect square. I have to take out a t. Okay, take out a t. That gives me t to the 4th minus 16. Sweet. Now, because I have the difference of squares, remember, difference means subtraction, okay? So I have subtraction of perfect squares, t to the 4 and 16. What I do is I'm going to take one parenthesis and put them into two. And in order to do that, I'm going to square root both of those numbers. What's the square root of t to the 4? T squared. I'm going to put that in both parentheses. Square root of 16 is 4. And then since it's a minus here, 1 is going to be a minus and 1 is going to be a plus. Okay? Always going to happen that way. Never both minuses and never both pluses. 1 negative, 1 positive. So in this problem, I have the t from the beginning. I have t squared minus 4 and t squared plus 4. Now if I look at this term here, aren't both of those perfect squares, and I'm subtracting. So it goes t, this one goes to t minus 2, t plus 2, and this one here goes to t squared plus 4. This is not, yes, they are both squares, but it's a plus. Okay, it's not addition of squares or sum of squares. It's difference. They had to be subtraction, so that doesn't work. So this next one here, again, I can't factor anything out. It's like this one here, I took out a t, right? This one I can't take out any number. But I look in, I got 81 and 100. Those are both perfect squares. And x to the 2 and y to the 8, those are also perfect squares. So I can square root them. Open my set of parentheses. Square root of 81x to the 2 is 9x, 9x. The square root of 100, y to the 8 is 10. Oops, hold on. Hold that thought. The square root of 100 is 10. 10. And y to the 8, the square root of y to the 8, remember it's y to the 4. And if some of you guys are like, well, how do I get y to the 4? Like, how do I know that? Remember, when I'm square rooting a variable, I just divide it by 2. Okay? If it's even, I just divide it by 2. I'm actually going to make this a little nicer because it looks really bad. 9x, remember, it's going to be, one's going to be plus, one's going to be minus. So minus 10y to the 4. Doesn't matter the order where the plus or minus goes. It doesn't matter. 9x plus 10y to the 4. Okay, there is your answer there. All right, let's go on to factor by grouping. This is going to be amazing. Factor by grouping can only work. It's a terrible can only work with 4 terms. Okay? Now it can work with more and you can do other things like that, but it can only work with a minimum of 4. Minimum, I guess minimum. You got to put minimum in there. Okay? So if I have 3 terms, that's not going to work. If I have 2 terms, that's not going to work. Okay? It's got to work with a minimum of 4. So what I do is I take the first 2 terms and I put parentheses around them. I take the last 2 terms and I put parentheses around those. And what I do is look at the first 2 terms, see if anything can be pulled out. Like, can a GCF come out of those? Well, 56 and 49, I can divide those by 7. V to the 3 and V to the 2, I can divide those by V to the 2, right? I can take out 2 V's. Now, what's left? 7 times 8, V squared times V. 7 times 7, V squared times nothing, so I'm good there. I do the same thing here. So I have a plus 48V minus 42. What can come out of those? Well, I can pull out a 6. Okay, plus 6. What's left? 6 times 8V and 6 times negative 7. Now, if I notice, what? These are the same. Okay, these are the same. If they are different, then you did it wrong, or the problem is not factorable. Okay, so if it's done correctly and it's factorable, then these should be the same. Now what happens, you're going to be like confused, but this is what happens. I take one of those and I take it out. Okay, write it down. Take one and write it down. Then next to it, I write down what's left. 7v squared plus 6. That is that expression factored. Okay, that's that expression factored. That's pretty cool, huh? Factor by grouping. This is something we do in Algebra 1 for certain areas. I taught it when I was in Goshen. We don't teach it here at Concord. Concord. All right, number 7. Let's look at it. What can I take out? So I remember this is 4 terms, so the first 2 are grouped together and the last 2 are grouped together. What can I take out? 42 and 147. Actually, I can take out a 7. Okay, take out a 7. I can take out an a squared, and I can take out a d squared, and that looks like to be it. What is left? 7 times 6. A squared, d squareds are good. C. So 6c. 7 times what is 47? That would be 21. 21. So that would be 21. A squared's good. D, I need a D right there. 1D right there. Actually, I can take out a 21. So let me go back here. This is what happened. So this is the reason why I didn't take out the right number. So I have a 6 and I have a 21. Okay. Those can both be divided by 3. So really I should have taken out a 21. 21.
What's 9 plus 10?
21.
A squared, D squared. Then I would have took out the 2C plus 7D. Okay, because now the numbers 2 and 7 are not nice. Okay, they don't work well with each other, so I'm good. But 6 and 21 they have a 3 in common, so I got to take that 3 again. So that doesn't work. You can do that to start, but you got to make sure you lead up to this right here. Now 36 and 126. Here's the deal. When the third term is negative, this third term is negative, you always want to pull out a negative. Okay? You always want to pull that negative out. It's a rule. You got to do it. Okay? Don't worry about the reasoning behind it. Just do it. Okay? Do it. What else? What can I pull out? 36 and 126. It looks like I can pull an 18 out. I can pull an 18 out. I can pull 1x. I can pull a d squared out. Okay, I can pull that and no c's. Fantastic. What's left? Well, what's left is 2. No x, no d's. There's a c there. Since I pulled a negative out, this makes it a positive. 18 times 7 is 126. And then the x and the d squared, I need a d right there. Okay, so now I'm going to write this next to it because you can see there very clearly. I can see clearly now, the rain is gone. I can see all obstacles in my way. Good song, everyone. You notice now these are the same, so I'm going to take one of those out, 2c plus 7d, and I'm going to write what's left. 21a squared d squared, 21a squared d squared, minus 18xd squared, minus 18xd squared. Okay, trying to think if I can do anything else. I could, if I really wanted to. I could take at least a 3d squared out of this one, and put that out front. I'm not worried about that right now, but that is good enough. It looks like 3, 6, 3, 7. Yeah, that looks pretty good right there. So that would be my answer there on number 7. All right, quadratic. Those of you that have been factored for a long time, you probably are like, yeah, I love these. I love it, love it. I like the wait, how does it go? I like to move it. I don't know. I was trying to sing something with love it. Oh, da 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 da. I'm loving it. There we go. The McDonald's one. Quadratic. Okay, so first I got to do is a GCF. If I can pull out a GCF, I cannot because they're not divisible. This is not divisible by 3. Oh, actually, it is divisible. Oh, shoot. Never mind. I lied. I can divide them by 3. So let's divide them by 3. That means I took out a 3. I get 3r squared minus 22r plus 35. Okay, that works out so much better. You have to do that. This is you have to. Number 2, then I'm going to make my x, right? So make my x. 3 times 35 is 105, and this is negative 22. What in the world is this? Oh, here we go. Yeah, negative 15 and negative 7 are my two numbers. Great. Okay, then I'm going to make my parenthesis. I'm going to put the negative 15 over here, put the negative 7 over here. Remember, I'm going to divide by the a value, which is 3. Okay, reduce if I can. This becomes a negative 5. So it's not x, it's r. Haha. Oops, I get divided by 3. Duh, I erased it. So then this becomes your negative 5. So it's negative 5. It's r, so it's r minus 5. This cannot be reduced, so this 3 is going to go in front of the variable, so 3r minus 7. And remember, the 3 that I took out at the beginning has to go in the very front. Okay, fantastic. All right, here we go. Let's keep going with some quadratic form. Factor out again. I remember GCF is first. Always, always, always. So I can take out a negative. When a is negative, always pull out that negative. Okay. What else? What else do I got? I got x to the 4 minus 8x squared minus 9. Sweet, sweet, sweet. And then I've already had that video. I don't want to show you that one again. Remember, I'm going to make my x. That's my second one. So negative 9, negative 8. I get negative 9 and positive 1. So make my parenthesis. I put a negative 9, a positive 1. I divide by 1 because that's what the a value is, right? The a value is right there. So this is really going to be x squared minus 9, x squared plus 1. And you're like, why is it x squared? Why is it x squared? Well, because it's x to the 4. Okay, what we do is we cut that number in half. Okay, we divide it by 2. If you look at this one, this will be a squared as well in both of your parentheses because I got to cut it in half. So I got to cut these in half. So now this is really negative 3, x squared minus 9, x squared plus 1. But I'm not done! Because, remember, this is a difference of squares. So it's really negative 3, parentheses. Okay, square root of x squared is x, square root of x squared is x, square root of 9 is 3, and 3. 1's plus, 1's minus. This is, again, both squares, but it's a sum. We don't have a sum. We don't have any rules for sums. So I am done right there. Okay, I'm done right there. This one up here, number 10. Nothing is in common, so that's where I go back to my x. There's no GCF, so I go to my x. I get negative 15, negative 2, negative 5, and positive 3. So it's going to be negative 5 and positive 3. I divide by the a value and the a value, so that's awesome. Then I take the value up here and I divide it by 2. So it's a squared minus 5b squared, because again, okay, that is also divided by 2, all right? So then I do the same here to get a squared plus 3b squared. And that is your answer there, because none of that is other factorable. They're not perfect squares. Okay, 0, product, property. You guys have seen this many times before. What this means that is if I have two things that are being multiplied, okay, a times b or something times something equals 0, then each of these are going to be split. So to say this is number 1 and number 2, then I'm going to take number 1 equals 0. I'm going to solve it. Okay, solve it like you did in 7th grade. And then I'm going to take number 2, and I'm going to solve that one again like you did in 7th grade, and you're going to get your answers. So if I look at my example here, I have 3 things that are being multiplied together. Okay, so this is A, this is B, and this is C. Okay, in this case it's AB, but if it's A, B, C, D, E, F equals 0, then that means one of them could be 0, or all of them could be 0. Okay, or some combination, so the same thing here. So I take each thing individual. I take the A piece, which is 3x equals 0. Divide, I get x equals 0. I take the B piece. Take 2x minus 8 equals 0. Add the 8. Then I'm going to divide by that 2, and x equals 4. Okay, that's your other answer. X equals 4. Then I'm going to take the C piece, and I get 4x plus 5 equals 0. 4x equals negative 5. X equals negative 5 over 4. And that's my third answer. In this case, you have 3 answers, and that's okay. Okay, that's okay. I want you guys to pause the video now. Try these 2. I know it's going to be hard, but I don't care, but try them!
I'm Slim Shady. Yes, I'm the real Shady. All you other Slim Shadys are just imitating. Pause the video.
All right, here we go. Thank you for unpausing. I know some of you probably didn't even pause it because you're like, I don't know how to do this. So first thing we got to do, first things first, I'm the realist. Something, let the whole world feel it. I'm in the, that's probably not appropriate for school. Let's skip that line. So awesome, Iggy Azalea, IGGY, got my name in bold. I'm gonna IGGY, got my name, I got changed the throw. Fantastic. I'm a big IGGY fan. Okay, here we go. First thing in an equation, okay, one side has to equal 0. So in this case, it equals 0, so I'm good. So now I can work on all of that stuff. Okay, great. So if I look up here, I notice I have 2 things, a couple different things that are going for me. One, there's 4 terms. So there's 4 terms. Remember, we were able to group by we were factor by grouping. So I'm going to take the first 2 terms, take the second 2 terms, and factor them. So I get x to the 4 times x minus 1. Okay, that's what I took out of here. This one is here. I'm taking out a 3x squared, and I get x minus 1 equals 0. So I get x to the 4 plus 3x squared times x minus 1 equals 0. That makes sense? Hopefully you'll see that's what we basically did up in the first couple examples. Now, I take this and I say, okay, can other stuff pop out of that? Like, can I pull other things out of that? Well, sure, they're both x's, so I can pull x squareds out, and I'm left with x squared plus 3 times x minus 1 equals 0. Okay? Hopefully we see that. I took x squared out. I'm left with x squared plus 3. Fantastic. Here we go now. Now, this is my A term, this is my B term, and this is my C term. I got to take them out, and I got to solve them. I get x squared equals 0. Remember, how do I solve a square? I got to square root it, but x is equal to 0, right? I can't square root of 0 because that's just 0 anyway. I take x squared plus 3 equals 0. X squared is equal to negative 3. Square root, x equals, when I square root in a problem, I get plus or minus, okay? Remember, the negative inside of a root is an I, square root of 3. Okay, those are my answers there. For C, I take x minus 1 equals 0, x equals positive 1. Fantastic. Yes. Those are my answers. Okay, x equals 0, x equals plus or minus I root 3, x equals 1. Number 12, make this 0, so I get 5x to the third minus 7x squared plus 6x equals 0. I can take out an x from all of them, so it's x times 5x squared minus 7x plus 6 equals 0. Let's factor. I get 30, negative 7. Is this going to work? Is this going to work? I don't think so. It's negative 6, negative 5. That would be negative 11, negative 10. This doesn't work. Why not? Let's make the 6x up here negative. Let's make that a negative 6x. And this makes it a negative. This makes that a negative. That makes that a negative. Now we're good. Negative 10, positive 3. All right. Well, I'm going to show you how to solve it this way, but then I'll show you how to do it the other way as well. So I get, let me factor that out. So I get negative 10 in my parentheses, and I get 3 as well. Divide by the a, which is 5. Okay. And then I get x times This is simplified as being x minus 2. And this is simplified as 5x plus 3 equals 0. So in this case, this is going to be 0. This case is 2. And this case is negative 3/5. And if you didn't know what I'm talking about there, set them equal to 0 and solve. Just flip the 3 and divide, flip the 2 and divide by 1. And this is no flipping, this is just 0. Okay, now, so that's what I did after I changed it. What happens if I ask you to solve this and it doesn't factor? Okay, it doesn't factor. So let me back up a little bit here. So again, it doesn't factor. Okay, so it's still minus 7x squared plus 6x equals 0. I still took the x out. Okay, and I got 5x squared minus 7x plus 6 equals 0. This did not factor. Okay, that's 30 and that's negative 7. So that did not factor. Remember from Algebra 1 and Algebra 2, we had a formula. It was called negative b plus or minus the square root of b squared minus 4ac over 2 times a. Remember, this is a quadratic formula, so the quad form. Okay, so I'm going to plug these values in to the a's, b's, and the c's. So this is our a, that's our b, that's our c. So I get negative of a negative is positive, 7. So 7 plus or minus the square root, b squared, 49, right? 7 squared is 49, minus 4 times 5 times 6 over 2a, which is 10, okay? Now let's reduce. 7 plus or minus the square root of 49. 6 times 5 is 30, times that is negative 120 over 10. That's 7 plus or minus the square root of negative 61. 71. 71. Sorry. 71 over 10, which is equal to 7 plus or minus I root 71 over 10. Okay, that is 2 answers right there. That's 2 answers. Then this x goes to 0. So I have these 2 answers and x equals 0. Okay, those are my 2 answers. Remember, quadratic formula. In 71, if I could break that down, then I would have to, but I cannot break 71 down. So I am done. All right, I showed you if it was factorable, and then I went back and showed you if it wasn't factorable. So there you go. That's enough practice, I think. You're going to ask questions. That's okay. But have fun. Please do your work. Please put some work into it, and it shouldn't be that bad. If you need extra practice, let me know. But other than that, deuces.